The 2573 ID fault locator will find earth return faults. An earth return fault is one in which an insulated conductor is physically making contact to the dirt due to some damage that has occurred to the insulation of that conductor. When fault locating, the first step is to isolate both ends of the faulted section of the cable. There should be no physical connection on either end of the cable. As with locating and marking cable path, understanding the path or circuit that the fault signal travels will improve your fault locating skills. The transmitter is connected to one end of the faulted conductor, and it sends a signal through this conductor. The signal travels through the good portion of the conductor until it encounters the fault. Because the far end of the target conductor is open or isolated, the fault provides the path of least resistance, so the signal returns through the dirt, back to the ground rod, and the black lead of the transmitter to complete the fault locating circuit. Fault locating is pinpointing the spot at which the transmitted signal leaves the conductor and re-enters the ground. When the transmitted fault signal reaches the fault, the signal radiates from that point, creating a pool of signal around the fault. This pool of signal is referred to as the area of detection. A pool of signal exactly equal to the signal pool around the fault exists at the ground rod. The areas are exactly the same size. The size of these pools is determined by the soil conditions and the severity of the fault. To measure the severity of the fault on this conductor, first ensure that both ends of the faulted conductor are open or isolated from any connection. Connect the red lead of the transmitter to the faulted conductor. Place the ground rod behind the transmitter in line with the suspected path of the conductor. Connect the black lead of the transmitter to the ground rod. Check the battery level of the transmitter by holding down the off key. Press the second key on the transmitter, which is the ohms key. A flag will light in the display above the ohm icon, indicating that the transmitter is in ohms mode. A resistance measurement will appear on the display. The lower the resistance of the fault locating circuit, the more severe the damage is to the insulation of the conductor. If OL appears on the display, this is an indication of an open line. This indicates that there is not an earth return fault on this conductor. Press the second key on the transmitter again to place the transmitter in fault mode. A flag will appear in the top portion of the display below the fault locating icon, and two locating frequencies, 577 Hz and 33 kHz, will flash alternately on the display. We will address the advantage of these locating frequencies later in this video. Connect the 3-foot A-frame cable to the A-frame, making sure the cable is completely seated. Then plug the A-frame cable into the receiver. It connects to the bottom of the receiver through a 1/4-inch jack. When the spike points of the A-frame are pressed into the ground, the A-frame becomes a two-dimensional sensor that will detect the fault. The receiver will calculate whether the green-banded leg or the red-banded leg is closer to the fault. Turn the receiver on by pressing the power key. From the main locate screen, press the command key below the word fault to place the receiver in fault locating mode. The receiver will immediately begin a momentary calibration mode, preparing to fault locate. It doesn't matter whether the A-frame is in the ground or not at this point. When the calibration is complete, step slightly in front of the ground rod, 1 A-frame distance, and push the A-frame into the soil with the green leg toward the fault. This is the point where you are going to record a reference reading of the fault signal. The numerical value that is displayed on the receiver screen is a number that you should remember. For convenience, you can save this reading by pressing the first yellow command key on the receiver labeled reference. The reference signal level at the ground rod will appear in the box above this key. Previously, we discussed that the fault pools created around the fault and the ground rod were equal in size. They are also equal in signal strength. When you have pinpointed the fault on the conductor, the signal strength at the fault will be within 12 dB or 12 points of the reference signal you measured at the ground rod. With the A-frame still inserted at the reference point, you will notice on the receiver that an arrow fills the screen toward the green band on the right side of the receiver. This is the indication that the fault is closer to the green leg of the A-frame than the red leg. Move the A-frame forward toward the green leg. Insert it into the ground again. Let the signal strength settle on the screen, then move the A-frame toward the red or green leg indicated by the receiver. It is not necessary to probe the ground every few feet. Divide the section into pieces and continue probing the ground until the arrow reverses. The receiver now points toward the red band on the left side of the screen, indicating that the red leg is now closer to the fault. Probe the ground back and forth until the fault is centered between the red and green legs of the A-frame. You have now located the fault two-dimensionally. You have centered the A-frame over the fault in the forward and backward position. Now you need to pinpoint the fault in the left-right direction. Turn the A-frame 90 degrees over the center point that you have just pinpointed. Watch the receiver screen for an indication whether the red or green leg is closer to the fault. Probe the ground moving left or right toward the red or green indication on the receiver until the arrows reverse again. Center the A-frame over the fault. Place your toe on the ground at the center point between the two legs of the A-frame. Turn the A-frame 90 degrees one more time to verify the forward and backward location of the fault. When the arrows on the receiver screen balance, the fault is under the center of the A-frame. Verify the fault location by placing the red banded spike into the pinpointed fault location. Insert the green leg into the ground randomly in a 360-degree circle around the fault point. Watch the receiver screen. Every time the green leg is inserted into the ground, the arrow on the receiver will point toward the red band on the left side of the screen, indicating that the red leg is always closer to the fault than the green. After the fault has been found, move the A-frame about 1 frame width away from the fault and insert into the ground with the green leg toward the fault. Note the signal level on the receiver screen. If this is the only fault on the line, or the most severe fault on the line, the numerical signal strength on the receiver screen will measure within 12 dB of the reference reading you took at the ground rod. This reference reading is in the bottom left corner of the screen, labeled REF for reference. If this signal level does not fall within 12 dB of the reference reading, there may be multiple faults on the line. Sometimes you will be fault locating on very long sections or in very bad soil conditions, and the fault signal pools may not overlap each other across the entire section of cable. You must be within one of these pools in order for your equipment to detect the direction of the fault. For example, you have a section of cable that is 100 feet long. There is a break in the insulation of this cable, causing an earth return fault at 50 feet. It is very likely that the areas of detection, or pools, will overlap on this short section of cable. You would never know that you have passed from one area of detection to the other. But if your section of cable is 2,000 feet long, and the fault is at 1,500 feet, the fault signal pools or areas of detection may not overlap. If this is the case, you may find that the receiver will seem to be confused in the middle of the section or not give you a strong indication of red or green. It only means that you have walked out of one of the fault signal pools and have not yet entered the second. This poolless area is sometimes called a dead zone. For example, if you lose fault indications 500 feet away from the transmitter, you have entered the dead zone. This dead zone will continue until you are within 500 feet of the fault. Then you will begin detecting the fault again because you have entered the fault pool. The transmitter sends two locating frequencies, 577 Hz and 33 kHz, simultaneously with the fault locating signal. These locating frequencies can help you get through the dead zone and stay on the cable path until you get closer to the fault, or walk back into the second fault pool. To switch the receiver into cable locate mode from the fault locate mode, press the OK key, then the yellow key under cable pipe. It is not necessary to unplug the A-frame while in cable locate mode. The cable locate screen will appear. Set the frequency of the receiver to 577 Hz or 33 kHz by pressing the yellow key labeled Frequency until 577 or 33K appears. Typically, 33 kHz will be the locating frequency you will use because of the high resistance of the fault and soil conditions. Press the OK key to acknowledge the frequency setting and enter the locating screen. It's easy to switch back to fault locating by pressing the OK key and pressing the yellow key under fault. Probe the ground with the A-frame to see if you have re-entered the second fault signal pool. If you have, you will see a steady red or green indication on the receiver screen. Continue following the indications from the receiver and the A-frame until the fault has been pinpointed as stated earlier in this chapter.